Hello again, Mr. Wakefield here, looking at section 4.2 now, and we're going to be kind of building off of what we did in section 4.1, where we had inequalities, one variable inequalities as we call them. And let me go ahead and take a look at that here for you, just a review. Remember, with the one variable linear inequalities, we would get x by itself, whatever was on the other side. You'd put that on the number line, and then it would always be shaded on either one side or the other. Okay, it wouldn't be shaded on both sides; it'd just be one side or the other. And then you did the interval notation at the end here. Okay, well, what we're going to be doing now is we're going to be looking at two inequalities, two of those same inequalities together, and it's either going to see how we got two inequalities right here, and sandwiched between those two inequalities is either going to be the word or it's going to be the word and. Okay, so you're going to see one of those two words, or and. Okay, and those two words mean two totally different things. In fact, we saw the word or earlier in the semester. It's a little bit different here, but there is some similarity, but please don't get it confused with that. It's a different enough of a thing now that don't get it confused with that. I'll explain what it means though. In fact, what I'm going to do right now though is I'm going to start out with the word and first, and then I'll come back and talk about the word or, because and is a little bit easier to understand, so it'll be a good way to start. But to get us started here, I'm going to give you sets of numbers here, because when you solve an inequality, that's like a set of numbers as well. And this is a much simpler set of numbers that we have here, and so it's easier to start off with this. Look at, see how I got a set of numbers, 1, 2, 3, and 4, and then 3, 4, 5, and 6. If I take two sets of numbers, okay, and I put the word and in between it, that is equal to what? That is equal to only the numbers that are in both of the sets. Which numbers are in both of these sets? In other words, which numbers are in this set and this set? That's why they use the word and. It's 3 and 4, isn't it? Isn't that true that 3 and 4 are the only two numbers that are in both of these sets here? Okay, the other ones are just in one set but not the other, like 1, 2, 5, and 6, right? Okay. So that's what we're getting at here when they have the word, and let's start out with this problem. Again, we'll get back to or in a minute here, so we'll skip this problem for the moment. But the word and means this. When you put two inequalities on each side of it, it means to solve those two inequalities, figure out what the two solution sets are, put them together, just like we put these two sets of numbers together, and then only pick out as your final answer, only pick out the numbers that are in both solution sets. Okay, that's how it's going to work. Let's do it carefully, one thing at a time here. So naturally, we would want to solve both of these things first so that we know what each individual solution set is for both of these. And then I'll get to that last part after that. Okay, in fact, it mentions it here. It says that when you solve this compound inequality, compound means that it has the word or the word and in between two inequalities. But when we solve this compound inequality, it's telling us to graph the solution sets for both inequalities on a number line, just like we did in the last section. Okay, and then after that, we'll do a third graph. That third graph will show the final answer. Okay, again, we'll get to that when we get to the third graph. So let's solve these. Just like in the last section, we treat them just like linear equations. Okay, we got a variable term and a couple of constant terms. So I need to move over the 2 with the -4. And that gives me this right here. And then I need to divide out the 3, right? But since it's +3, I do not flip the inequality symbol, right? Because you're dividing by a positive. Let's do the same thing with the other one. We got to move over the 1 with the 5. So that we can get a single variable term on one side and a single constant term on the other side. And then when you do have that, that's when you divide out, right? Again, I divided by a positive, so you do not flip the inequality symbol, and you get that right there. Okay. The word and is still in between that. So what I'm going to do is I'm going to do a number line, just like we did in 4.1, for each of the two inequalities that we found. Okay, and it's very important for everything to line up. So since -2 is a smaller number than 3, we're still going to put it on two separate number lines here, but when we do it, make sure the -2 is further to the left than the 3 is. Otherwise, it's going to get you all messed up, okay? Because -2 is smaller than 3, it's always to the left of 3. Even though it's on two separate number lines, that's very important. As you'll see coming up here, we want everything to line up according to where the number should be. All right, now, as we talked about in the last section as well, when we do the shading part, which we got to do after we put the number on there, right? Okay, if the alligator is eating the variable, we go to the right, correct? We go to the right. But when the alligator is not eating the variable, like right here, the alligator is not eating the variable, it's eating the 3, then that means it goes to the left of 3, doesn't it? Okay, got a little sloppy there, excuse me. Let me fix that. Okay, so make sure to shade this in so that it's clear that this part is a solution and this is not. So this should be a fatter line then, and this should be a skinny line, so I can tell the difference there and I can see where your answer is, okay? Anyway, notice that both of these have feet underneath the alligator mouth, and so that means that the -2 has a square bracket, and so does the 3. Okay. Alligator feet, alligator feet next to the number means square bracket next to that number in the number line. Okay. We'll again revisit and review when you have a round bracket instead of a square bracket coming up here in some other problems that we do. But in the meantime, what we need to do is we need to do a third number line. A third number line now, and here's what you do. Very important. I need you to take those two numbers that you put on the previous two number lines up here, and I want you to drop them straight down. That's one of the reasons why you need to put them in the correct place originally, where the -2 is to the left of the 3. Drop it straight down so it'll make sense. And then here's what you do. Okay, remember we said the word and means both, right? It has to be in both sets. Okay, so what this does when you bring these two numbers down is it breaks this final number line up into 3 intervals here. And we're going to look at one interval at a time here. We'll look at this interval in this right here. We'll look at the middle interval here. You don't have to draw these lines here. I'm just helping you visualize it better. So we're going to look at this interval, and this interval. Let's look at the first interval. Notice in the first interval, it's shaded not in the first graph, but in the second one. That means this right here. In fact, let me show you. See how the numbers 5 and 6 are not in the first set, but they're in the second one? That's the same thing as this right here. It's not in the first, but it's in the second. The numbers are not shaded in the first, but they are shaded in the second. Okay? So just like we did not put 5, 6 in the answer because it was only in one of the sets here, same thing with these numbers here from -infinity all the way up to -2. They're only shaded once. Okay, when you have the word and, you only put it in the final answer if it's shaded both times. You only put it in the answer if it's shaded both times. So since this interval is only shaded in the second graph but not the first one, we do not shade that. If we were to shade that, that would mean that would be an answer. That would be part of the answer. But it's not supposed to be because it has to be shaded both times when the word and is being used. Just like right here, 3 and 4 were the only numbers in the answer because they were the only ones that were in both sets. Okay? So it has to be shaded both times in order to put it in the final shading. Speaking of that, notice that the middle interval is shaded both times right here, all right? From -2 to 3, it's shaded both times right here. In this graph, from -2 to 3. In this graph, the second graph here, from -2 to 3, both of them are shaded. And so both, as long as it's shaded both times, all right, it's going to be a part of the final answer when you are doing the word and. But it has to be both. And for that reason, you guys, that's why this final interval here is not going to be shaded. Okay? It is shaded in the first graph, but not the second one. So it's just like the numbers 1 and 2 right here. 1 and 2 were in the first one, but not in the second one. In the same way, it's shaded in the first one, but not the second one. So just like I left out 1, 2 right here because it wasn't shaded both times, or it wasn't in both of these solutions, in the same way, it's not shaded both times here, and so you don't shade it in the final answer. Okay? So that's it. Now, once you do your shadings, though, and you've tested out all the intervals and you've shaded the correct things, remember I mentioned in 4.1 as well that whenever you have a shading that is, whenever you have a number, whenever you have a number that's shaded on one side of the number but not the other, and you can see that that's the case here with both of these. Both of these numbers, -2 and 3, they're shaded on one side but not the other side of that number, of that mark there for each one of those numbers. When that happens, just like in the last section, when it's on one side but not the other, you have to close it up with a bracket of some sort. The way you figure out the type of bracket you use is the same as in the last section. Okay, if -2 has an alligator foot next to it, we use a square bracket. Is same thing with 3. If it's got an alligator foot next to the 3, you use a square bracket on that as well. Okay. And so once you've done your shadings and you've done your brackets, wherever you see a shading on just one side of a number but not the other, that's when you need the bracket. Okay. Once you've done the brackets as well as the shadings, you're now done with the number line, the final number line. Okay. And then as it says up here in the directions, very important. Okay, use the third graph to put the final solution set in interval notation. In other words, you cannot figure out the interval notation for each one of these two individually and then just kind of put them together in the final answer. You can't do that. You have to actually come up with the third graph. Okay, that way I know that you are able to do that, that you're able to actually figure out what numbers go in the final graph. And then after you do the third graph, that's when you do the interval notation. You only need to do the interval notation on the final graph, though, not the first two. Okay? So what is the interval notation on that third and final graph here? It's going to be, starts at -2, the shading starts at -2, and it ends at 3. Okay? And so then we use square brackets for both of those, because as we said before, unless you have infinity or negative infinity in your interval notation, all other numbers, the brackets are determined by whatever the graph says. So since -2 is square and 3 is square, -2 and 3 are also going to be square brackets here. Okay. Not all interval notation has infinity or negative infinity, and I know we've always seen it that way, but this is not going to have that, because see how when it goes forever to the right here, it's infinity, and whenever it goes forever to the left, it's negative infinity. Then neither one of those things happen here. The shadings did not go all the way over here, and the shadings did not go all the way over here either. And so that's why you don't see any infinity or negative infinity here. Don't be surprised by that. That's just the way it worked out this time. Okay, so let's go on into the next problem here. More of the same stuff. Okay, we need to solve both of these inequalities first. I get x is less than 8. I need to, and you don't need to divide out there. X is already by itself. And then over on this one, you need to move over the 4 with the 14 and then divide out. Excuse me. And so you, since we're dividing by +2, you don't have to flip the inequality. And then we got x by itself there. So once again, we're going to do our 3 number lines anytime you have a compound inequality with the and the or in between. Okay, you're going to, you know, like when you have 2 inequalities with the and the or in between. Okay, whenever you see that, you're going to have these 3 number lines that you got to do. Okay, the first 2 number lines are for what? They are for to figure out the solutions to each of the individual 2 inequalities that you just solved. Again, make sure that 8 is to the right of the 5, because 8 is bigger than 5. The bigger numbers always are to the right. And you can see here on both of these, the x is not getting eaten by the alligator mouth, right? the 8 and the 5 are. And so what does that mean when the alligator is not eating the variable? It means that it goes to the left. So both of these go to the left then. Okay. The alligator is not eating the variable in either one. Okay, so just like in 4.1, all right, we know that if the alligator doesn't want to eat the variable, we go to the left. And since we have an alligator mouth next to both the 8 and the 5 here that does not have alligator feet, that means that we're going to use a round bracket on those, right? Like that. So once you're done with your shadings and your brackets, okay, we then now can move on to the third graph. Remember, a number line is done when you're done with your any shadings and any and all shadings that you need to do, and the brackets as well. Okay, remember that brackets are needed when you have a shading on just one side of the number. So we did all that. Bring the 5 and the 8 straight down like this, and then we do the same thing we did in the last problem. Okay, we break this up into 3 intervals here. Okay, the first interval is shaded both times. What does that mean? The word and means if it's shaded both times, then it's also going to go into the answer. Okay, just like 3 and 4 were both times right here, and so they went into the answer over here. But only the ones that were both times went into the answer. And so since this interval right here is shaded both times, it's going to go into the answer also, just like the 3 and the 4. Okay. If you look at the next interval, it's shaded the first time but not the second time. So with the word and, that doesn't count. Okay, just the ones that are shaded both times. So don't shade this one in the final answer. And then over here, it's not shaded either time. So again, if it's not shaded either time, then that doesn't count for both times either, obviously, right? So don't shade that one either. You only shade it when it's shaded both times, okay, if it's the word and. The word or is going to be different. We'll get to that. The word and, it has to be shaded both times in order to bring the shading down here. Okay, now, you don't need to put a bracket here on the number 8 because remember, only if it's shaded on one side or the other side, okay, one side but not the other side. Well, in the case of 8, it's not shaded on either side. So that whole thing about being shaded on one side would not count here with the 8. You don't need to put a bracket there. The 5, however, is shaded on one side of it, on the left side of it in particular, so I do need to put a bracket there. What bracket is it going to be? Again, since 5 has an alligator mouth next to it that does not have alligator feet underneath it, we are once again going to use the same thing we always use when the alligator doesn't have feet underneath him, and that is the round bracket. And then based off of that last graph right there, and only off of that last graph, not the 2 previous graphs, you do your final interval notation answer. Okay. So this right here is the final solution here on the number line. Every number from negative infinity all the way up to 5, not including 5 because the round bracket means that 5 is not included, just the numbers next to it. Anyway, that's how you say it in English, but we're going to write it down mathematically here by not only doing the number line like we just did, but also the interval notation. Interval notation means that we start from the left and we go to the right, correct? And so we need to start out at negative infinity because that's where the shading starts, and the shading goes all the way up to 5. Remember, infinity and negative infinity always have a round bracket next to it. And then the 5 has a round bracket because the number line tells us that it does. Okay, there we go. One more here. It's going to look different in the final answer than the other one, so just want to make sure you've seen it since it's a little bit different. Let's go ahead and proceed as normal here. I'm going to distribute this out like this. Over here, I need to just move over the 6, right? So I'm going to get this right here. But this other problem here, we got some work to do. Okay. Like that. And so I still need to divide out by the 5 to get the x by itself on this one. And so I end up with that right there, right? So I've got x greater than 5 or x less than or equal to -2. Okay. You know what? Actually, that double arrow I put there is kind of in the way. It's just a reminder that there's another page coming up here that I sometimes put there. But so let me move the number lines down here so it doesn't get in the way. There we go. There we go. And first one, we're going to put the 5. Second one, we're going to put -2. Again, it doesn't matter where you put the 5 and the -2 as long as the smaller number, -2, is further to the left than the 5 is. And then we do that thing with the alligator mouth. Okay, if the alligator mouth is eating the variable, we go to the right. That. And if it's not eating the variable, okay, you can see here that it's eating the -2, not the variable. That means it's going to go to the left, correct? Okay. And then we do our brackets because each one of these numbers, 5 and -2, are shaded on only one side, so brackets are necessary. And 5 has no feet underneath it. Oh, I'm sorry. No feet means round, my bad. So fix that there. No feet means round. There we go. But the -2 does have feet underneath it, next to it, and so that's going to be square. Okay. So one round and one square this time. So we're now done with the shadings on the first two number lines. We bring the -2 down. We bring the 5 down. And we do the same thing we've been doing. Okay, we break this up into 3 parts. We look at each part. Okay, and since the word is and, we only shade the final answer if it's shaded both times right above it, right? Just like right here, we shaded this part of the final answer, this interval, because it was shaded both times right above it. Okay, same thing up here. I only shaded this part because it was shaded both times up above it. Is there anything that's shaded both times up above it? No, okay? Look at the first interval. It's shaded only one time here, but not the other. The middle interval is not shaded either time. And as we said over here, okay, that's definitely not going to get shaded either. Okay, neither is not the same thing as both, obviously, right? Okay, so we're not going to shade this either. And then in this last one here, it's shaded the first time but not the second time. So you don't have a situation where both of the things up above the final line are shaded. Okay, you don't have both. You don't have it shaded both times in any one of these 3 intervals, and so you don't shade anything. Okay. Since you don't shade anything, you're not going to have any brackets either because you only have brackets when it's shaded on one side of a number. Well, that's certainly not the case here. What happens when you have a completely empty number line after you try to do your shadings? This probably won't surprise you, but no solution. Because remember, the shading is where the solutions are located. So if there's no shadings, there's no solution. Okay? And there you go. Now, let's go ahead and look at the second page here. I'm going to ask you guys to try some here. You'll see that in problems 1 and 2, it has the word and, so please try those 2 problems. Problems 3 and 4 have the word or, so do not touch those yet, please, because we haven't talked about how to do or yet. Okay, so just do 1 and 2. Hit the play button after that. We'll look at the answers, and then we'll talk about the word or. Number 1. We got to get x by itself on both of these. I did that right here, and I ended up with 5 and -3 as the 2 numbers that go with the x's there. Okay, do not flip the inequalities on either of those because you divided by a positive on both of those. Here are the 2 numbers lines that you would get, not the third one yet. We'll get to that in a minute. But here are the 2 number lines that you would get from these 2 inequalities. Okay, you can see it looks very similar to problem B on the front. Okay. So then we bring the negative 3 and the 5 straight down, okay? And that's going to once again break it up into 3 intervals. Which of the 3 intervals, though, is shaded both times, which is a requirement with the word and? Wouldn't it be the middle interval there? Okay, the middle interval is the only one that's shaded both times right above it there. The first interval is only shaded the first time, but not the second time. This last interval over here from 5 to infinity, that area right there, it's shaded not the first time, but the second time. Okay, and means you only bring it down into the final answer if it's shaded both times. So we now have this as our interval notation here. And I should mention how we got the brackets as well. I apologize. 5 is square because the 5 has alligator feet next to it. The negative 3 has a round bracket next to it because it doesn't have alligator feet on the alligator that's next to negative 3. Okay? And so that's where the brackets came from. Let's take a look at number 2 now. Number 2, if we solve these, I went ahead and moved the 4x over with the 2x and the 1 over with the 3. And I ended up with this right here. But you may have chosen to move the x over to the right instead of over to the left like I did. Okay? If you did that, then you divide by 2. And dividing by 2 means you don't flip the inequality. I had to divide by negative 2 based on how mine is written. Okay, and even though our answers look different here, they do mean the same thing because you have x and negative 1 in both of these answers here, and here. You have x in the answer in both of those. You have negative 1 in the answer for both of those. And the alligator is eating the same thing. As long as the alligator is eating the same thing, it doesn't matter what side the x is on. Okay, mine could be on the left and yours could be on the right. And as long as the alligator is still eating the negative 1 on both of them, okay, both of our answers, therefore, are the same. And therefore, they're correct. Okay, same thing over here. I decided to move my x to the left. If you had decided to move them to the right, okay, and I didn't write the whole thing out. Let me go ahead and do that. If you had decided to move the x's over to the right, it would look like this right here. 2x on the right, and it would look like negative 6 over here on the left. And then if you divide out the 2 here, you get this answer right here. I had to divide by negative 2, which meant that I had to flip the inequality because I divided by a negative. And you can see that these two answers here, this one here and this one here, are both the same answer because the alligator is eating the negative 3 in both of them. And so they are equivalent even though they look different. They're written in a different order and all that, okay? Anyway, here's what the two graphs look like, the two initial graphs before I get to the final graph. Negative 1, remember, has to be to the right of negative 3 because negative 1 is bigger. Okay. And then round bracket because there's no alligator feet. Square bracket for the negative 3 because there is alligator feet next to the negative 3. All right. Anyway. And then, of course, the x's are not getting eaten by the alligator in either one of these, and so both of the graphs then have to go to the left. This brings us to the last step here. Notice it breaks it up into 3 intervals again, okay, with negative 3 and negative 1 coming down. All right, which of the 3 intervals are going to be shaded? Okay, well, it's just going to be the first one, right? Because the first one is the only one that is shaded both times right above it there, from negative infinity up to negative 3. All right, this middle interval is only shaded once, and the last interval from negative 1 to infinity is not shaded either time. So only the first interval comes down into the final answer there. Now that I have that final answer, as a number line anyway, what's the interval notation version of the final answer if you put it in interval notation? You go from negative infinity up to negative 3 with the appropriate brackets, as we've talked about as well. Okay? So that's number 2. And that is the word and what you do when you have two inequalities with the word and in between it. That's what that means. Okay? Now, what about the word or? The word or. Okay. It's gonna the process of the problem is exactly the same when you have the word or. The only difference is at the end. The way you do the end is different. So we're not going to be completely doing something totally different here. It's just the end part that's going to be different. Anyway, since just the end part is different, I'm going to go ahead and jump right into this first or problem here on the front side, or the first page of the section here, and I'm going to get x by itself on both of these. All right, and that's going to get us started here. Once again, after we get x by itself, we do our two number lines, the two initial number lines before we get to the third one. So you're going to have three number lines again. It doesn't matter if you have the word and or the word or with your two inequalities sandwiched around it. Either way, you're going to have your three number lines. The difference, like I said, is at the end when you do the third number line. The first two number lines, you're going to do it the same way you did before. Okay, you take the 1 and the 5, you bring that down like this. There you go. And then, again, you're going to do it the same way. Since the alligator's not eating the x right here, that means that the graph is going to go to the left. But then on the other one, because the alligator is eating the variable next to the 5 there, that means it's going to go to the right of 5. Like that. Okay? We need to do our brackets, and since both of these numbers 1 and 5 have no alligator feet next to them, we're going to do a round bracket on both of those. Like that. Okay. Now you bring down the 1 and the 5. And then here's the part where it's different. Okay, here's the part where it's different. Let's go over this carefully. Before I show you what the final graph is going to be, let's go back to that thing I was talking about here, where we had the two sets on the piece of scratch paper right here. You don't have to write this down here with these numbers right here. This is just an example to help you understand it better. What does the word or mean when you have two solution sets sandwiched around it? It means that any number that is either in the first set or the second set, and that both counts for that. Okay, if a number is in both sets, that also counts. But let me say it one more time. Any number that is either in the first set or the second set or both counts, would then go into the final answer. So what are all the numbers that are either in the first or the second or both? Wouldn't it be all the numbers from 1 through 6 here? Okay. 1 and 2 is in the first one. 5 and 6 is in the second one. Okay. 3 and 4 is in both of them. Remember, either the first one, there's the first one right there, or the second one, there's the second one, or both. Okay, if you are a number, if you have a number that is in either the first or the second or both of them, it has to go into the final answer when you have the word or. Okay, so that's why all 6 of those are in there. The difference with the word and is that you only put the numbers that are in both in the answer. Here you just put everything in there that occurs at least once. You can think of it that way as well. All right, any number that occurs at least once, and that includes twice because the words at least means it could be more than once. Okay, so any numbers that occur at least once have to go into the final answer if it's the word or. If the word and is being used, then it's only the numbers that occur both times, twice, in other words, twice only. Okay, so we're going to take that same approach here. All right. Remember we said with the word and, it was only the shadings that occurred twice, right? It's only the shadings that were shaded both times. Okay. Since we're talking about at least once right now, then anything that's shaded at least once here is going to drop down into the answer. Anything that's shaded at least once. So notice here that this first interval from negative infinity up to the number 1, that's shaded the first time but not the second time. Okay, so it's shaded at least one time. Okay, anything that's shaded once or twice, either one of those things, it's going to go in the answer. Okay, so we're going to shade this here. So with the word or, you guys, there's two different ways it could go into the answer. If it's shaded once, but not the other time, it still goes into the answer. If it's shaded both times, it will go into the answer as well. Remember we said that both counts. That's why we put 3 and 4 in here. Okay, so with the word or, if it's shaded once, you drop it down in the answer. If it's shaded twice, you still drop it down into the answer. The only time you wouldn't put it into the answer is if it wasn't shaded at all, because that would be the opposite of once or twice, would be none at all. And speaking of that, that's what we have here in the middle. This interval right here is not shaded either time, so you don't shade it in the answer. Okay. How about this last interval from 5 to infinity? Well, if you look up above it here, it's shaded one time, the second time, but not the first time. So that means that we shade it in the final answer as well. Okay, anything that's shaded once goes into the final answer. Anything that's shaded twice goes into the final answer. Okay, when you're doing the word or. I'm going to put round brackets here because, as you know, 5 and 1 have no alligator feet next to it, so 5 and 1 have to have round brackets. Okay, how do we write out this answer here? Let's talk about that for just a moment. Okay, let me just remind you from back in chapter 2, we saw number lines there as well with the domain problems. Okay, remember we said back in those problems there, if the shading is going from left to right and then it temporarily stops but then starts back up again, we have to stop it and start it, and then we put the word or in between it. Not because this is an or problem that we're doing right now, but you could do that here. Okay, you could put the word or in between. I'll get to that in a minute. There's another way to write it as well. I'll mention that too. But it's that same idea though. You start on the left. The shading goes from negative infinity all the way up to 1, right? Okay. Negative infinity is always round. 1 is round because the graph tells us that it is. And then here's the thing. You could put the word or right here, just like we did back in 2.3. Like I said, when it stops, the shading stops and starts. Okay, you could put the word or here, but there's an alternate way to do that, and it's the letter U. The letter U. It's like you're unionizing or uniting the two parts of the answer together here. Okay, U stands for union for that reason. Okay, and then where does it start back up? It starts back up at 5. Okay, and then it goes all the way to infinity, as you can see there. 5 is round because the graph tells us that it is. Infinity is always round no matter what, so I'll put in a round bracket for that as well. Okay, and so there's your final answer. By the way, you guys, some of you might be wondering, and I totally don't blame you for this, why is it that we're using the letter U here in this section, but over here in this section we use the word or? Okay, for some reason the textbook does that, and when they present the answers in the back of the book for 2.3, they use the word or whenever the shading stops and starts back up again. But then in chapter 4, it uses the letter U for that same situation. I have no idea why they do that, but in order to avoid confusion for when you guys watch my videos and then look at the answers in the back of the book to check your homework and stuff, that's why I'm going to do it the same way the textbook does it, just to avoid any kind of confusion. Okay, so that's why I use the letter U here, but you could use the word or. Not because this is an or problem, but because the letter U and the word or are either one of those things can be used when the shading stops and then starts back up again as you're moving from left to right. Here it stops at 1 and then it starts back up at 5, and so that's an example of that. Okay. So one more time. When do we shade it in the final answer? If it's the word or, you shade it in the final answer. If it's shaded once, and if it's shaded twice, you also shade it in the final answer. The only time you wouldn't shade it when it's the word or is if it's not shaded either time. But the word and, only if it's shaded both times do you bring it down into the answer. That's the difference. So please try those two problems on the second page that have not been attempted yet, problems 3 and 4. They're both OR problems, and then we'll wrap things up here after you hit the play button. Okay, number 3. There it is right there. Okay, so we need to move the 5 over with the 11 and then divide out the 2. That gives us the 8. We move over the 1 on this one, subtract it over, and then divide out the 5, and it gives us the 1 on the other side there. So we have 8 and 1. Okay. Let me erase this out of here. Then we bring down the 8 and the 1 here, right? The 8 and the 1. Make sure the 8 is to the right of the 1 since it's bigger. And since the alligator is not eating the variable, we go to the left on the 8. Since it is eating the variable on the 1, we go to the right of 1. And so creates kind of an interesting problem here. All right. Hopefully it didn't throw you off, but if it did, we'll talk about it right now. And don't worry, no pressure here. All right. We're going to be looking at the answer right here. Notice that, again, the word OR means what? It means that if it's shaded once, you put it in the answer. If it's shaded twice, you put it in the answer also. The first interval here is shaded once, but not the other time, so you put it in the answer. The middle interval is shaded both times, so you put it in the answer. The last interval is shaded not the first, but the second time, so it's shaded once. So all 3 of them are going to be in the answer because all 3 of them qualify as being shaded either once or in the case of the middle one, twice. All right. If it's shaded at least one time, you put it in the answer. All 3 of these intervals are shaded at least one time. Okay. Once, twice, once, right? In that order. And so every one of them is at least once. Now, as I told you guys, you only do the brackets if the number has a shading on just one side of it. Notice that the number 1 and the number 8 have a shading on both sides of it. In other words, the shading just goes right through it on both sides of the number 1 and on both sides of the number 8. When it's shaded on both sides, you don't need a bracket. Okay, just when it's shaded on one side. So the number line, this third number line is complete now. No brackets needed, and we already did the shadings. Okay, notice that it's just completely shaded from one end of the line to the other. That means all real numbers, but how do you write all real numbers in interval notation? And it's all real numbers, by the way, because everything's shaded. All the numbers are shaded. But the way you write that is just like you'd expect when you do interval notation. It's from negative infinity all the way to positive infinity with no breaks, and so you don't have anything where you'd have to put the word or the letter U in it, okay, because there's no breaks where the shading stops and then starts again. It just goes straight from negative infinity on the shading all the way over to positive infinity. So that's how you do that. Okay. Problem number 4. I need to move over the 16 right here, subtract it over, I get negative 24. Remember, when you divide by a negative, though, you have to flip the inequality. So we get 8 again, but remember, it flips the inequality. Why is that so important to remember to flip that here? It's important not just in these problems, but it's especially important in these problems for the reason that, remember we said that the direction that your shading goes depends on what the alligator is eating. And so if you correctly flip the thing around, it's not going to be eating the same thing anymore. If you had forgotten to flip this around, it would be eating the variable, which would mean that it would have to go to the right. But since you correctly flipped it around, it's now eating the number instead of the variable. And so it's going to be going a completely different direction. It's going to be going to the left, as you can see right here. Okay, over here I moved the x's over to the right, which meant that I divided by a positive, so the inequality doesn't flip. But once again, the alligator is not interested in eating the variable, and so therefore, once again, the shading goes to the left because the alligator is eating the number, not the variable. Okay. Finally, third graph. Okay. Notice here it once again breaks up into 3 intervals with the 2 and the 8 coming down. Which intervals are shaded in the final answer? Well, Look at the first interval here, from negative infinity all the way up to positive 2. It's shaded both times. That counts, right? If it's shaded twice, the word or means that you bring it down into the answer. The next interval is shaded only one time, from 2 to 8. It's shaded on the first graph, but not the second one. So we bring that down into the answer. See how I brought it? I brought down the shading down for both the first interval and the second interval as well. Why did I not shade the third interval though? It's because once or twice means that's not the same thing as none, right? Okay, so none, if it's not shaded either time, then you don't want to shade that when it's the word or. Okay. So that's one of the things that or and have in common. Whether it's or if it's and, you're not going to be shading it if it's not shaded either time. Okay. So we just have the first two intervals shaded. Do not put a bracket on the 2 because, like I said a minute ago in the last problem here, if the shading is on both sides of the 2, you don't need a bracket there. You don't want a bracket there. Okay. But the 8 needs a bracket because it's shaded on only one side of the 8 but not the other side of it. And so we need a bracket there. Why did I choose a square bracket? It's because 8 has a alligator foot next to it, as you can see right here. Okay. All right. So now that I have my shadings and I've got the bracket that I need, we can see that the interval notation starts at negative infinity and it goes all the way up to 8 with no break in between there. Just because the 2 is there doesn't mean there's a break there. That was just where we divided up the intervals. But the shading goes straight through there, so it goes straight from negative infinity all the way up to 8. Okay? But again, the shading goes straight through, just like it does here with the 1 and the 8. Okay? And so you just go straight from negative infinity to positive 8. And that concludes our discussion of or. So now we know what the word or means and what the word and means when you're doing a compound inequality where you have an inequality on both sides of the word and or the word or. Okay, so that's section 4.2. All right, so let me know if you have any questions about that. You have a good day, and we'll be talking a little bit. We'll be revisiting some of this stuff in 4.3, so make sure to make sure that you really got this down, and let me know if you have any questions about that to make sure that you have it completely down solid, okay, before you move on to 4.3. Okay, and we'll see you back for that 4.3 video.